Here's a lab problem from section 5.3. It says to evaluate the integral. The integral is going to be an integral from 3 to 4 of 3 plus 2y quantity squared dy. And so if we're going to integrate this, we don't have any special techniques yet, and so the best thing to do at this point is to FOIL everything out. So if we take this and expand it, we will have a 9 for the first term. We have 3 times 2 is 6, and we double that, we get 12 for the middle term, and then we square this, we're going to get 4y squared. Now that it's expanded, we remember that the derivative of x to the n is going to be x to the n plus 1 divided by n plus 1. And then if we have a constant sticking out there, we'll just leave the constant out there and just take the derivative by itself. And so our nice and easy polynomial that was already FOILed out will be an easy antiderivative to take. So the antiderivative of 9 is going to be 9y. The antiderivative of 12y is going to be 12 times y squared over 2. So we need to take half of 12. And then the antiderivative of this is going to be 4, is left out here. And then we add 1 to the power, which makes 3, and then we divide by that same power. So now our antiderivative is going to be 9y plus 6y squared plus 4/3 y to the third power. And so we want to evaluate this at 4 and at 3. To evaluate, we're going to substitute 4 in, and then 3 in, and then subtract. So when we put 4 in there, we get 9 times 4, 6 times 4 squared, so that's 6 times 16 is 96. And then we have 4/3 times, we need 4 to the third power. So 4 times 4 times 4, 4 times 4 is 16, times 4 is 64, times another 4. That's going to be that's going to be 256. So 256 for our numerator there. And then now we have to add them all up. So we need a common denominator 3. Let's see. All right. Let's make some fractions. We got 36 plus 96 plus 256 divided by 3. And so the common denominator is 3. We're going to need to multiply 36 times 3. I think that's 108. And we got 96 times 3 is 288. And now we add them all up. So 288, 108, plus 256. So this is going to end up being equal to 652, and I don't know if that's divisible by 3, so maybe we should just leave it like that. 652. All right, we have to do the same thing by putting 3 in. So this is going to be 9 times 3 plus 6 times 3 times 6 times 9 is 54. And then we're going to have 3 cubed, and that's going to knock out one of the 3, so that's just going to be 3 squared times 4. 9 times 4 is 36. And so now we simply add these 3 numbers, 36 plus 54 plus 27. I think this is going to be 117. So let's put 117 here. Okay, now that we have those numbers, we essentially have these 2 things to subtract. Let's see, if we want to have this over 3, and that's going to be 117 times 3, it's 21, 2, 5, 3, 51. Divided by 3, and then we subtract, so that's 301 over 3, which I don't think it's divisible, or is not a perfect number. Alright, so that's it. So you see that the easy part, the calculus is the easy part over here, getting this antiderivative. The difficult part is the arithmetic, where you put in those numbers and try to get your numerical value. Okay, hope that helps.